Assalamu alaikum students. Today's lecture is on chapter number 3 integration, exercise 3.1, question number 2. Using differentials, find dy by dx and dx by dy in following equations. Part number 1, xy plus x is equal to 4. Taking differential on both sides, derivative of xy plus derivative of x is equal to derivative of 4. As we know that here x and y are multiplying to each other, so we will use product formula which state derivative of first, second as it is, plus first as it is, derivative of second, plus dx is equal to 0. Y dx plus x dy plus dx is equal to 0. Now we will move the values containing dx to the other side, which will give us x dy is equal to negative y dx negative dx. Now we will take common negative and dx, which will give us the equation x dy is equal to negative bracket y plus 1 bracket of dx. We will move this dx to the other side, which will give us our first answer, dy over dx is equal to negative bracket y plus 1 bracket of divided by x. For dxy dy, we will reciprocate the fraction, which will give us dx over dy is equal to negative x over y plus 1. Part number 2, x square plus 2y square is equal to 16. Taking differential on both sides, derivative of x square, derivative of y square and derivative of 16. For this we will get 2x dx. For y square we will get 2y, which will 2 multiplied by 2 give us 4y dy is equal to, as we know that derivative of constant is always 0, so derivative of 16 is 0. Now we will move this value containing dy to the other side, which will give us 2x dx is equal to negative 4y dy. Now we will move this value here and this value here, which will give us dy over dx is equal to negative 2x over 4y, which is equal to, now cancelling these terms, we will get negative x over 2y. Now next step is reciprocating the fraction, which will give us dx over dy is equal to negative 2y over x. Third part, x4 plus y square is equal to xy whole square. Taking differential on both sides, derivative of x4, derivative of x square and derivative of xy square. For x4 we will get 4x cube dx, for y square we will get 2y dy, and for xy square we will get derivative of first, second as it is, plus first as it is, derivative of second. Here the statement remains same. For this part, dx would become dx, and for y square it will be stated as same. For x it will be x, for derivative of y square we will get 2 dy dy. Moving the values containing dy to one side and values containing dx to the other, we get 2y dy minus 2xy dy is equal to y square dx minus 4x cube dx. Taking dy common from these two values, we get dy common 2y minus 2xy. From these, taking dx common, we get dx bracket y square minus 4x cube. Now moving dx to the other side and this equation to the other side, we get dy over dx is equal to y square minus 4x cube, and also taking common 2y from these two equations, we get 1 minus x. For dx we will reciprocate the fraction, we get dx over dy is equal to 2y into x minus 1. We will get 1 minus x over 4x cube minus y cube. For fourth part, we have xy minus ln x is equal to c. Taking differential on both sides, derivative of xy minus derivative of ln x is equal to derivative of c. As x and y are multiplying to each other, so we will use product formula which state derivative of first, second as it is, plus first as it is, derivative of second, minus 1 over x dx is equal to 0. Here it will become x dy is equal to 1 over x dx minus y dx. Taking dx common, we get 1 over x minus y. Now taking LCM here, we get x dy is equal to 1 minus xy over x into dx. Moving dx to the other side and x to this side, we get dy over dx is equal to 1 minus xy over x square. Reciprocating the fraction, we get dx over dy is equal to x square over 1 minus xy. This concludes our lecture for today.